Okay, so we're going to go ahead and do an average velocity problem. Problem says, John travels by car from one city to another. He drives for 30 minutes at 100 kilometers per hour, 25 minutes at 80 kilometers per hour, and 30 minutes at 50 kilometers per hour, and he spends 20 minutes eating lunch and buying gas. So, we're driving a car along here. We could draw the car for each section, but I'm not going to have a whole lot of space left. So I'm simply going to draw one car here. And then if we look up here, there are 4 different parts to this problem. The first part, he drives for 30 minutes at 100 kilometers per hour. So we're going to write down the givens for that for part 1. So I'm going to write minutes as a time, and it's part 1, so I'm going to put a little subscript 1 there. And it is 30 minutes. And then 100 kilometers per hour, that's a speed. There's no direction given, so it's not a velocity, but it's 100 kilometers per hour. And that is speed 1. Okay, part 2. He goes for 25 minutes at 80 kilometers per hour. So 25 minutes at 80 kilometers per hour. Part 3, he goes for 30 minutes at 50 kilometers per hour. And then part 4, he spends 20 minutes eating lunch and buying gas. So I'm going to go with he's not going anywhere. He's hanging out at the gas station, which means his speed is 0 kilometers per hour. Back up here, part A, determine the total distance traveled. Well, distance can be written as x. So we are trying to find the total distance traveled. Equation, the equation that has speed, distance, and time is speed is equal to the change in distance over the change in time. Substitutions. So let's start with part 1 because we can't substitute all of this in at once, so we're going to do each part and then find the distance and add them all up. So for part 1, the speed is 100 kilometers per hour. And that is equal to the distance, which we don't know, over the time of 30 minutes. So to solve this, multiply both sides by 30 minutes. Over here it'll cancel, which is great. Over here we will get 3,000 kilometers per hour times minutes. That is not what I wanted. I wanted hours to cancel, but hours and minutes don't cancel. So we need the units to be the same for our time. We can't have hours for one part and minutes for another. So I'm going to go ahead and make all of the minutes into hours. 30 minutes is half an hour, which is as a decimal 0.5. 25 minutes, well, 25 minutes. I want minutes to cancel, so I'll put it in the denominator. I want to have hours, so put it in the numerator. I know there are 60 minutes in 1 hour. 25 times 1 divided by 60 is 0.42. Part 3, 30 minutes, half an hour again, 0.5. And part 4, 20 minutes, 20 times 1 divided by 60, 0.33 hours. Okay, now we are ready to solve the problem. So now we've got 100 is equal to the distance over half an hour, and the hours will cancel this time. Multiply both sides by 1/2. 0.5 times 100 is 50. So in part 1, John went 50 kilometers. Right, part 2. John was going 80 kilometers per hour. We don't know how far he went, but he was going that speed for 0.42 hours. Multiply both sides by 0.42 hours, and in part 2 we will determine that John went 33 6/10 kilometers. Okay, part 3. John was traveling at 50 kilometers per hour for half of an hour. Multiply both sides by 0.5, and we will get that he went 25 kilometers during part 3. Part 4 is intuitive, but we'll write our workout anyways. It was going 0 kilometers per hour for 33 hundredths of an hour. Multiply both sides, and he did not go anywhere, which makes sense. Now to find our total distance traveled, we simply add them all up. So 50 plus 33.6 plus 25 plus 0, and we get the total distance that John traveled was 108 6/10 kilometers. All right, now for part B. Determine the average speed of his trip. Okay, average speed. Well, to find the average speed, we need the total distance over the total time. Well, we just found the total distance, 108.6 kilometers. We need the total time, so now I need to add half an hour plus 42 hundredths of an hour plus another half of an hour plus 33 hundredths of an hour. Add those up, we will get 1 75 hundredths of an hour. And that will give us a speed of 62 6/100 kilometers per hour. It did not ask for a direction, nor did it ever give us a direction, so this is just a speed, not a velocity.